This short video demonstrates results achieved in a testing program collaboration between NASA Kennedy Space Center and Honeybee Robotics of New York under an innovative partnership program funding. The testing involves a percussive cone penetrometer developed by Honeybee Robotics and a use of JSC1A regolith simulant with deionized water, various percents of water ice. We used paint cans initially and then a tall 1 meter tube to simulate or try to investigate the possibility of penetrating to depths of about 1 meter in ice-bound regolith in support of potentially developing a lunar surface cone penetrometer to prospect for water ice. This paint can with 4, 5, and 6% water ice JSC1A shows no penetration at all under quasi-static loading, and then 7.5 centimeters of penetration under percussive cone penetration. Up to 200 newtons under percussion was used to get to 7.5 centimeters, and then no further penetration was possible with increased loading. Testing then proceeded on to the much larger 1 meter tube to try to simulate cone penetrometer penetrating to 1 meter depths on the lunar surface. What's interesting here is that using alternating layers of icy regolith with dry regolith allowed the cone penetrometer to penetrate all the way down and beyond 6% into 8% water ice under a very low load, just the weight of the percussor, approximately 6.5 kilograms. The theory is that the dry layers in between, of which layers were approximately 10 centimeters, alternating icy and dry, the dry layers allowing a place for the icy regolith to be displaced to, unlike with the paint cans, which were all ice, albeit smaller. And finally, data plotted for the 1 meter column of icy regolith clearly shows penetration rate through dry layers and icy layers, and indicating a reduced penetration rate with depth and increasing ice percentage. Also showing the faster penetration rate through the dry layers. The data is valid all the way through the 6% layer. The cone did touch the sidewall beyond that. It is interesting to note that the cone penetrometer did make it beyond the 6% layer with low downforce, only the mass of the cone, whereas in the paint cans where there were no dry layers, even under the weight of 2 people, cone penetration stopped at 5%, only went down to 7.5 centimeters.